Hey, welcome. In this video, you're going to learn about a special communication pattern that the collection view uses to talk to the view controller. And this is very important because we're going to be using this concept in all of the apps that we'll be building together. Furthermore, it's not just the collection view that uses this pattern, but there are many other elements in Uikit that do the same thing. Now, I'm going to warn you, it may be a little bit hard to understand at first, but I'm going to use a lot of examples and analogies. And I highly recommend that at the end of this video, you download that worksheet and you try out the examples and get some hands-on training. All right, enough talking. Let's do this.
First, let me illustrate what the problem is. So far, we've mostly been adding user interface elements to the storyboard and then connecting them to IB outlet properties in the view controller so that the view controller can reference them and manipulate them. For example, if the view controller needs to disable the button after the user submits a form, it has the submit button IB outlet property to do so. All of this communication is one way. The view controller instructs the elements to do things. The view controller knows about the UI text field class, it knows about the UI label class, it knows about the UI button class, and it knows that this UI button class has a property called enabled that it can set to false if it wants to disable that button. Now let me ask you a question. What if the UI button needed to ask the view controller for some information? How do we make that communication two-way? The UI text field, UI label, and UI button classes are all Uikit classes. So as we're coding the view controller class, we know about all of these Uikit classes and all of the methods and properties that they contain. So we can have our view controller class call on these properties and methods of these Uikit classes. However, the reverse isn't true. The UI text field, UI label, and UI button knows nothing about the view controller class. They don't even know that this class exists. Furthermore, we're able to create custom classes as you saw in the last lesson. The UI text field, UI label, and UI button wouldn't know about those either. Let's use a more concrete example. In the last lesson, we set up our project and right now it looks a little like this. The view controller has a reference to the UI collection view element through the IB outlet property so it can manage and manipulate the collection view. However, the way that the UI collection view class works is that it only displays enough information to fill up the screen. So for example, if you had 1,000 pieces of data to show and only 3 would fit on the screen, the collection view would only show 3. It does this for performance reasons. If it displayed all 1,000, even if only 3 were visible, chances are your phone would be very slow and sluggish as it starts to run out of memory. When the user starts to scroll the collection view, it is at this point the collection view would ask for the next 3 pieces of data. This means that the UI collection view element needs a way to ask the view controller for the next 3 pieces of data. But the problem is, the UI collection view class doesn't know about the view controller class. So this is the problem. How will the UI collection view ask the view controller for data even if it doesn't know anything about the view controller class? Well, let me tell you how by using an analogy. Let's say that there's a police officer who stumbles upon a crime and she needs to call it in. So she grabs her radio, connects to a dispatcher, and tells the dispatcher some codes to indicate what sort of crime it is. The dispatcher understands the codes and dispatches the necessary emergency vehicles. Now let's examine this scenario. When the officer connects to a dispatcher, she doesn't care who is on the other line. She doesn't know the dispatcher's name, gender, height, and weight. None of it matters. The only thing that matters is that the dispatcher knows the protocol. What is the protocol? Well, in this case, it's a set of predefined codes that can be used for communication. So when the officer tells the dispatcher, we've got a 902, she expects the dispatcher to understand this code and react to it accordingly. It works because they are both following the same protocol. Let's label this scenario with some iOS terminology. Now we've already established that there's a protocol. Let's say that there's an officer class too, and this officer is an instance of that class. The officer has a radio, right? This radio represents the property that the officer class uses in order to have a reference to the other party in this communication pattern. And in case you forgot, you learned all about properties back in Module 1. Now again, The officer has a radio property that references another object on the other end of the line. The officer doesn't care what or who this object is. It can be a person, it can be a dog, a cat, an alien. As long as it conforms to the protocol and understands the codes, then it's all good. This other party is called the delegate. So the property on the officer's side is sometimes called the delegate property. Let's run through this scenario again, this time using iOS terminology. The officer object discovers a crime and then uses its delegate property to report the crime. The delegate property references another object, which is an unknown class type. However, this class conforms to the protocol. The protocol lists some methods and properties that can be used for communication. The police object uses one of these methods and calls it on the object that is referenced by the delegate property. Since the delegate object conforms to the protocol, it has implemented all of the required properties and methods that has been outlined by the protocol. This is how the officer object can call a method on the delegate object, even though it doesn't know what class type it is. The officer object knows that as long as the delegate object conforms to that protocol, it is sure to have the methods and properties listed in the protocol. So here I've got a brand new playground, and all I've done is declare two empty classes to represent the two parties in the communication pattern. Following the diagram that we just talked about, the officer, which is going to report the crime, to the dispatcher, which is going to listen for the codes and then go do something with it. So first of all, what's missing here is the protocol that these two parties are going to use to communicate. So let us establish a protocol, and the keyword to use there is simply protocol, and we have to give this protocol a name. So I'm just going to call it police codes. So pardon my ignorance. If you actually are a police officer, you are probably just laughing your head off at me right now. Anyways, in this protocol called police codes, I am going to have a method inside called let's use the example that we used earlier in the diagram. I'll just name this 902 like that. And we are not actually implementing this function here right in the protocol. That's the job of the dispatcher, who is going to conform to that protocol. So all you need to do is just list out in this protocol that anybody who follows this police codes protocol will need to implement this method. Now, as we talked about before in our analogy, the police officer class has a delegate property, and this delegate property references the other party in this communication. So in this officer class, we are going to create a delegate property, and most of the time you are going to be naming it delegate, but in this case, because I want to make it very, very clear and follow that analogy that I used, I'm actually going to call this radio, just so you remember that this property references the object on the other end of the line. So the funny thing is that a protocol like this one, police codes, is also considered a type. So we can say that this property, this radio property here, is going to be a type of police codes. And furthermore, because we don't know if there's going to be anyone at the other end of the line when the officer tries to use the radio, this has to be able to return nil. And you learned in the optionals lesson that you can specify this property is an optional by using the question mark. So this property may reference nothing, or it may reference an actual object that conforms to the police codes protocol. Okay, so now that we have our officer class with a delegate property, we are going to create a function or a method here. And when this method is called, it is going to call in the 902 code via the radio. So we are going to call this one, maybe we'll just say call it in. That's my method name. And inside this method name, we are going to say radio dot 902. And remember, this radio is a property that references some object that conforms to police codes. And since police codes lists this method, we know that whoever is on the other line will have this method. And this question mark here is just called optional chaining. What happens is that when we try to call this method, If it happens that the radio property is nil, then this is not going to crash. However, if there is an object that the radio property is referencing, then it's going to attempt to call 902 on that object. So now why don't we create our objects and try to facilitate the communication? So let's use, I'm going to say var O stands for officer, and I'm going to create a new officer object. I'm going to say var D is equal to a dispatcher object. And actually we can use the let keyword. We can use the constants because these aren't going to be changing. And next, what we have to do is we have to set our dispatcher object as the person on the other end of the radio for this officer. So we are going to say O.radio is equal to D. Unfortunately, we are going to get an error. We can't assign this dispatcher object to the radio property. And the reason is because we've never said that the dispatcher class conforms to the police codes protocol. And if it doesn't conform to the police codes protocol, we cannot set it to this property here. Because as we stated here with the data type, whoever sets itself to the radio property must conform to police codes. So how do we get the dispatcher class to conform to the police codes protocol? Well, what we have to do is use this notation, and you might recognize this from the inheritance lesson. You use colon, and then you put in the name of the protocol there. And just like that, we are able to say that the dispatcher class conforms to this protocol. Xcode asks us to double check. It says that dispatcher does not conform to that protocol because we haven't implemented all of the required methods and properties of that protocol. All right, so that's what we have to do in here. We have to say, we have to actually implement this, and let's say that the dispatcher, when it receives a 902 code, it's going to print, something 902 received and handled or something like that. And so now this line is valid. We can set this dispatcher object to the radio property. And now when we call the callItIn method, you can see that the dispatcher has received that code and it has printed out this statement. Now take a look at how cool this is, because in the officer class, there is no reference to the dispatcher class, right? The officer class has no idea that this dispatcher class even exists. The reason that the officer class can communicate to the dispatcher class is all because of the protocol and delegate pattern. So just to walk through this again, we have an officer object, we have a dispatcher object. We are setting the dispatcher object to the delegate property of the officer object. And because the dispatcher object conforms to the police codes protocol, the officer object, even though it has no idea about the dispatcher class and what methods or properties might be in the dispatcher class, it knows at least that the dispatcher class has all of the things that are listed in the protocol. Now, it might still be hazy to you, but we are going to implement this in the Match app, and then there's also a worksheet for you to run through some exercises to wrap your head around this whole protocol and delegate thing. And it's actually a very important pattern because a lot of the classes in Uikit use this pattern to communicate with other classes without knowing about them. All right, let's go back to our Xcode project and see how the UI collection view uses the protocol and delegate pattern. All right, so here we have our Xcode project, and as you can see, we do have this collection view in our storyboard. And as it turns out, we actually do not have an IB outlet property referencing that collection view yet, so we have to do that connection. Let's go to the assistant editor, go back to the storyboard. On the left-hand side, we should see this document outline, and you can always hit this button to expand or collapse it. On the right-hand side, you should be seeing the viewcontroller.swift, and just to double check, you can click this little breadcrumb and go to automatic and go to view controller. If you have this part highlighted, if you have some element highlighted in there, if you go to automatic, it should select the right corresponding complementary file. All right, so we are going to highlight collection view, hold down control, and click and drag it just right there. And I'm going to call this the collection view. So now we have an IB outlet property. Let's go back to the view controller here. And if I moved a little faster, I just click this button to go back to the standard editor. All right, so now that we have this collection view, let's take a look at the Uikit documentation for this class. And I want to show you the protocol that it uses and also the delegate property. If you hold down Option on your keyboard, you're going to get this question mark as you learned in Module 2, and you can jump to the class reference. Now, right here, it jumped to the UI collection view delegate, but let's go up here. This is what I wanted, the class documentation for UI collection view. Now, scrolling down a little bit to where we see all of the properties and methods of this class, you can see that here is the delegate property for the class, and here is the type, basically the protocol that's associated with this delegate property, and this protocol is called UI collection view delegate. Down here, you can actually see that listed here. And if you click into it, you're going to see all of the methods and properties that are in that protocol. Now, I just want to mention that a lot of these are actually optional. So if the delegate doesn't handle the optional methods, it's fine. Nothing's going to happen, but there are a couple that are absolutely required. And I will go through those when we actually implement it in Xcode. Now, it's hard to tell actually which ones are required and which ones are optional from this documentation, but just based on my experience, I know which ones are required. And also, when you state that your class conforms to this protocol, if you haven't implemented one of the required methods, it's going to let you know. So you're going to get an error. So that's kind of through this trial and error, you're going to understand which ones are required. If we go back for a second into the UI collection view, actually, I want to point out that there are two protocols. Where were we here? Right here. There are actually two protocols that the UI collection view class uses to communicate with other classes. And that second protocol is this one, UI collection view data source. So the collection view uses this protocol to ask for the data source to power that grid layout, right, for the items to display in that grid. And for this protocol, the UI collection view delegate, this one is for the collection view to let other classes know when certain events happen, such as the user selecting a cell in the grid. So as such, there are actually two delegate properties with the UI collection view class. The first one is this one we already went over. This property is called delegate. So whoever is assigned to this delegate property must conform to this protocol, and that object will get notified when certain events happen in the collection view, such as the user tapping on a cell. Now, someone else, it could be the same object, needs to assign itself to this other delegate property called Datasource. Now, don't get fooled that this property is called Datasource and not delegate, because in our police officer example, our delegate property was called radio. Right? So this one's called Datasource. Whoever assigns itself to Datasource must conform to the UI collection view Datasource protocol, and the collection view will be asking this object for data to show in the collection view. So for our match app, we are going to be assigning the view controller to both the data source property and the delegate property. And as a result, our view controller needs to conform to both of these protocols. Okay, so let's jump back into our view controller class and make this happen. So first of all, if you remember back from the playground, in order to state that your class conforms to a protocol, use this colon, and then you state the protocol name after it. So right here, we actually have a superclass because the view controller is a subclass of UI view controller. That's completely okay, because what we can do is we can put comma, and then we can do UI collection view delegate, comma, UI collection view data source. And like this, you can actually have your class conform to multiple protocols and at the same time be a subclass of another class. Now, Xcode is going to complain right away because it detects that we state that we conform to these two protocols, yet we haven't implemented the required methods for those protocols yet. Before I do that, though, there's one step that we need to take care of, because Oftentimes, I still forget this sometimes. So I usually try to do it as soon as I can, and that is setting the view controller as the delegate for the collection view. We can do that in the viewDidLoad method here. So we have a reference to collection view. Let's access the delegate property, and let's assign the view controller, which we can use the self keyword for, and assign that to delegate. Remember I said that we're going to assign the view controller to the data source as well. So let's set the data source property also to self. So if you're confused about this part, remember back in the playground with the officer example, we had created an officer object and a dispatcher object, and then we had set that dispatcher object to the radio property of the officer, right? So we're doing the same thing here. We're setting the view controller to the delegate and the data source properties of the collection view. So when the collection view needs data, it is going to communicate with the view controller through the methods stated in this protocol. And when the collection view needs to notify another class about events happening to the collection view, such as the user tapping on the grid, it's going to tell whoever is assigned to the delegate, which is the view controller, and it's going to communicate through the methods listed out in this protocol. All right, so now it's time to get rid of these errors here. We need to implement the methods that are required in these two protocols. So usually what I like to do is create a separate section for these sort of protocol methods, and you can do that by using this mark keyword, and it's basically a comment. I'm going to call this the UI collection view protocol methods. And you can see what happens when you pull down this kind of jump list to all of the properties and methods, that you see this section header here. And this is created by this line here. So it's a quick and easy way to organize your code within a class. We're going to start by implementing the required methods of the data source protocol first. So one of them are the number of items in section. So the collection view is actually going to ask its delegate for the number of data items that it needs to display, and this is the method that it does it through. So that's why inside the view controller we must implement this method. We basically have to return a number for the number of items that are going to get displayed. That's really easy for us because we have actually gotten the cards from the model and set it into card array. So all we need to do is return the card array dot count. Okay, and another one that we have to implement is when the collection view asks the data source, which is our view controller, for new data to display for each individual cell that it needs to display. So this method is actually called, you can't even see the whole thing, but it's this one right here. If you just start typing cell 4, you're usually going to get the right one. Let me show you that again. So you can see that kind of highlighted there. If you double click that, this is the cell for item at index path. And the index path basically describes which cell the collection view is asking for. It comes with two different parameters, a section and a row. So the section is usually just the first section unless you have multiple sections in a collection view, which you can have. And the second property is a row, which is almost like an index in an array. So if it were trying to display the first item and you only have one section in your collection view, the section would be 0 and the row would be 0 as well. And what you need to return is a UI collection view cell object, which is basically a cell in your collection view. So what we can do in here, first of all, let's create a constant so we can assign our cell to it. And then at the end here, we are going to just return that cell. So the collection view actually has a method called DQ reusable cell with reuse identifier for index path. And this method will basically try to get a cell that it can reuse, maybe a cell that's scrolled out of view, or it will create a new one. So the type of cell that it's going to create is based on this reuse identifier. Now, where is this identifier? Well, if you remember back in our storyboard when we created this card cell right here, and if we went to the properties here, we gave it a identifier. We called it card cell. So when we put in this identifier to that DQ method, it is going to try to get an existing card cell which has been scrolled out of view and is no longer visible so that it can reuse it, or it's going to create a brand new one. So either way, we're going to get a cell back. So inside here, this reuse identifier parameter, we are going to put in card cell. And for index path, we are just going to pass in this index path that it was asking for, and we get back a cell. Now, how do I know this method returns a UI collection view cell? Well, let me show you. When you use dot notation and you hit dot right there, this left part tells you the return type of calling this method. So when you call this method DQ reusable cell, you're going to get back an object of type UI collection view cell. All right, so that's how you know. Let me just undo. There we go. And so that's why this constant cell is going to be pointing to a UI collection view cell object, and then we can simply return that cell. All right, so now as for the second protocol that we have to implement, there is not required but optional, and we will need it. It is did select item at. So I've been talking about this throughout this video. This event happens when the user taps on a cell in the grid. So we're going to want to capture that. I'm just going to leave this as a to-do right now, or empty. But this protocol method is part of the UI collection view delegate protocol, which is this guy right here. All right, so let's run our app right now. So hopefully what we will see is a grid of cards. So while that similar loads, let me just remind you of what we did in this card model here. See, in the get cards method, we had randomly generated 8 pairs of cards. That means there are 16 cards. When we go into the view controller and the collection view asks for the number of items, we are going to return card array.count, which is going to be 16. And so this one where it asks for the cell is actually going to be called 16 times, one for each cell that it needs to display. All right, so it did load up, and you can kind of see the white background of the collection view, but we can get rid of that. So you can see right there, there are 16. 4 rows of 4. So hopefully you got this result too. If you didn't, I would just double check that you remembered these 2 lines, because it's very important to set the view controller as that object that the collection view should contact for any events that happen in the grid, as well as for the data that is going to power the grid. And if you do have these 2 lines and it's still not showing anything, what I would do is just double check that model.getCards is in fact returning some card objects into the card array. It could be that your card array is empty, and that's why you're not seeing anything in the grid. And actually, one more improvement we could do is probably just call getCards before assigning the collection view, .delegate and .datasource.
So, what do you think? Was it easier or was it harder than you thought? Either way, I would highly recommend that you download that worksheet to practice this concept. In that worksheet, you'll be implementing the collection view in a demo project. If you do the worksheet and you still don't understand it, please leave a comment below telling me which part confuses you or what you're having trouble with, and I'll jump in to clarify, or maybe a fellow student will. Lastly, if you like this video and you want to see more, please consider subscribing by hitting that red subscribe button below. And if you want to get notified when new videos come out, remember to hit that bell icon as well. Okay, thanks for watching, and I'll see you in the next lesson.